So this is a video in response to some questions about a particular finger trick that's used to do certain multiplication problems. For example, 8 times 7 here. And so I want to just show how that particular trick is working and justify algebraically why it's supposed to work. Okay, so I've got an example here, 8 times 7, and since I don't want to just tie this explanation to this specific example, we'll call those two numbers, the numbers we're trying to multiply together, x and y, right? So we're trying to multiply two numbers together, x times y, or in this case, 8 times 7, right? And so the way the finger trick is supposed to work is we take that first number, 8, and that tells us to extend 3 fingers and curl 2 fingers in, right? And so the way that works is our thumb is supposed to be the 6, our pointer finger is supposed to be the 7, the middle finger is the 8. So we extend all 3 of those fingers, in this case on our left hand, right? And then we do a similar thing for the other number, 7, for the right hand. So 7 is the pointer finger, so we're going to extend the pointer finger along with the thumb. So then at this point, really what we're just doing is we're counting the number of extended fingers, right? And so on the left hand, we have 3 fingers extended. On the right hand, we have 2 fingers extended, right? So I'm going to represent those with L and R, right? So in the first case, on the left hand, L is supposed to be 3. And we're going to tie that back to our original numbers x and y by doing x minus 5. That's what gets us to 3. Okay? And then likewise on the right hand side, the 2 fingers that are extended, that's r, right? And we can get that from taking the original number y, which was 7, and subtract 5 from it. Okay? And it might not seem clear right now why I'm bothering to do that, but what we want to understand is how the trick works. So we want to tie what we know and what we're going to do with L and R there, the number of fingers that are extended, right, back to the original numbers we were working with, right? So the way the trick works is we're supposed to say, okay, well, the number of fingers extended total is L plus R, that's 5, right? That's the number of tens we're supposed to have. So the number of tens is L plus R. The number of ones, we take the curled fingers, right, the fingers that weren't extended on each hand, and we multiply them together, right? So on the on the left hand, the number of curled fingers, that's 2, and we can get that by taking 5 minus the number of fingers that are extended, right? And then we do the same on the right hand. So 5 minus the number of fingers extended will give us the number of fingers curled in. Right. So those two expressions there tell us the number of tens we're supposed to get and the number of ones we're supposed to get. But they're both in terms of L and R, right? And so if I want to see how this is connected back to the original numbers we're multiplying together, I need to get them in terms of x and y, right? So that's where these equations L equals x minus 5 and R equals y minus 5 come into play, right? So we're just going to go into these two expressions and substitute those in for L and R. Right. So for example, if we look at the number of tens, that's supposed to be L plus R. So we're just going to replace L with x minus 5 and R with y minus 5. And doing a little simplifying here, that just turns into x plus 5 and then minus 10 because we're subtracting 5 twice. Okay. And then likewise, we look at what we got for the number of ones, right? So 5 minus L times 5 minus R. So this one's going to look a little funkier, but we replace L with x minus 5. Right? And we replace R with y minus 5. Okay? And doing a little bit of simplifying here within the first set of parentheses, that's just 10 minus x. And within the second set of parentheses, that's 10 minus y. Okay? Now from here, we can distribute and multiply, right? And so we've got 10 times 10 is 100, negative x times 10 is negative 10x, 10 times negative y is negative 10y, and then negative x times negative y is xy, right? So here we have the number of tens and the number of ones we're supposed to have in our answer in terms of x and y, the original numbers we're multiplying. So what we want to see is how does this actually work? So if we have the number of tens in a number and the number of ones in that same number, we can get the value of that number by taking the number of tens times 10 and then add on the number of ones. Right? So the number of tens we got above was x plus y minus 10. So we're going to take all of that and multiply it by 10. And then once we've got that, we'll add on the expression that we got for the number of ones. Okay, so simplifying the first half of that, we're going to multiply through by the 10 there, and so we'll have 10x plus 10y minus 100, right? And then the brackets are unnecessary on the second half of that expression, so we can just drop those. And then so now we see that we have quite a few like terms that we can combine. For example, I've got a positive 10x and a negative 10x, so that we can zero those out. Okay, and we've also got a positive 10y and a negative 10y. Those will zero out as well. And then finally we've got a negative 100 plus 100. Those zero out. And that leaves us with just x times y. So what we're saying is that all of what we just did before gives us the product x times y, which is what we were trying to find initially. Right? So this proves to us why that finger trick works using a little bit of algebra.